Okay, well, thank you very much. Thank you very much for having me. So the title magically disappeared, but it should lead from Aristotle to Galileo and back. The title is misleading. I'm not a historian at all. I'm not a specialist on Aristotle or Galileo, so well, I don't know anything, almost anything about Aristotle and Galileo, but I think, well, I want to talk a little bit something that is related to Aristotelian way of thinking and Galilean way of thinking, and also that nicely connects to Professor Suzuki's talk and also the hard concept on the monokuyo, actually, because I'm talking about mono objects. So, but before that, this is a bit about what I work usually. So I work in the philosophy, but more in the scientific context. I work in the evolutionary biology using the causal modeling, so using causal modeling to evolutionary dynamics. And also, I wrote a book on the philosophy of statistics. And recently, I use some kind of more mathematical tools like category theory to understand the causality and statistics and so on. And finally, I'm interested in machine learning and AI as well. And I think that the AI and the machine learning helps us understand what concepts are, which has been a fundamental question in philosophy. So, so this side is a more kind of a philosophy, this side is more kind of mathematics. And here I work in the causality. Causality is one of my main research topics. And here, in the more related to statistics and machine learning. So I work in the kind of interdisciplinary. But anyway, today's talk is not about that. So it's about paradigm shift, but paradigm shift in philosophy. So, and especially I'm interested in philosophical ontology. So what is ontology? What ontology is about our theory of what are there, what are there, what populate this world. And the main claim is that summarizing this slide. So there are two kinds of ontologies, roughly speaking. One is thing ontologies, which say that there are things, or things like this. And there are event ontology. The event exists that we are gathering today. It's a fundamental existence. And I'm talking here, it is also an event, and so on. So these are two ways of understanding ontology. And historically speaking, the modern scientific revolution induced a change in the ontological shift from thing ontology to event ontology, at least in philosophy. I don't know about physics, but in philosophy, yes. So what I want to talk today is maybe we might be going back from event ontology to the thing ontology thanks to the contemporary development in AI. So that's kind of provocative kind of talk agenda today. So, okay, so let's start. What do you see here? First, let me start this question. What do you see here? What did you see? Well, you might say the red ball caused the blue ball's motion. Well, yeah, of course. Well, and from more abstract way of thinking, something, red ball is a thing, caused another thing, which is a blue ball. Well, motion of blue ball, but anyway. So this idea is a kind of this is the idea that the causal relationships is a relationship among or between things. This is a very intuitive picture, and this is indeed the very old idea. I call this object or object-oriented ontology or thing-based ontology. I use these words interchangeably. The basic idea is this: the world is populated by things or objects. And then within this ontology, this ontology sets a kind of research agenda. So object properties determine how it behaves, right? So according to this idea, and this is actually an Aristotelian idea, the object has some intrinsic properties which we call essence or nature. So I have my own nature, which makes me to think in particular way and behave in certain ways, right? Well, it's quite interesting, quite intuitive. So this is a kind of inherent principle or kind of program of an object. And Aristotle saw that there are 4 elements: fire, air, water, and earth. The fire has by nature has a tendency to go up, and the air also, but earth by its own nature go down below. So in combination of these natures, Aristotle explained how objects behave naturally. But also there are accidental properties. For example, think about kind of slowing a lock or something. The lock does not have its nature to move kind of in a horizontal way, but this kind of force is inputted or imposed by me. This kind of project there is explained by this property of impetus or imposed force. Force is kind of forced by other objects. So the combinations of these inherent and accidental properties explain object behavior and movement and so on. So this is a kind of quite Aristotelian picture of things. So in this worldview, science, well, of course, science is kind of very modern word. It was invented in the 20th century. So it's kind of anachronistic to call this science. But anyway, the study of nature, the goal of study of nature is to discover things' nature and how they interact with each other. Quite intuitive picture. Okay, so this is a thing ontology. Next, event view, event-based ontology. So again, what did you see? Well, another way to look at this is the collision caused the motion of the blue ball, right? Collision is not a thing. It is something that happened, right? It happens. So it's an event. So in this picture, it is some event that caused another event. This is also quite intuitive picture, I think. So this is a very rough kind of picture right now. So this is a very rough historical picture. So there are a lot of problems with this picture. But anyway, in a very simplistic caricatured picture, the rays of modern science kind of optimize this kind of shift from object and nature-based view to events and law-based view. So events here are understood as a state of affairs at a given time and location. For example, the collision, or a ball, or more specifically speaking, a ball is at X, a particular position, or is particular velocity V at time T, and so on. Well, I'm not a physician, so I cannot be more specific than that. But anyway, these kind of things. And of course, there are laws that connect these events, right? Relationship among events. So if a ball is fully falling with a velocity v at time t, then it's going to be blah, blah, blah. And we have Galileo's free-fall rule to explain or to concretely compute how these events are related to each other. So laws are kind of relationships among events. And David Hume, the philosopher in the 18th century, kind of took this kind of event-based ontology quite seriously and redefined causal relationship in terms of the relationship between events. So according to Hume, well, this is not really historically very accurate. Actually, it was not Hume, but actually another guy who really kind of started this kind of thinking. But anyway, Hume is often thought as a kind of the typical kind of proponents of event-based causation, according to which causal relationships are kind of relationship in a constant conjunction, maybe in a modern term correlation between events. And I think this event-based viewpoint is quite popular, and I think this is more standard in today's science. For example, think about state space or phase space. Phase space, each point in the phase space is an event, right? And the law is a kind of law determines the flow in the state space. So that determines how a particular event evolves into another event. So this is a kind of quite event-based ontology. And also in the statistics as well. Statistics, the base of statistics is the sample space, and any, the subset of sample space is called events. And events are denoted by random variables and the combination of random variables and its values. And laws determine the kind of probability distribution over these events. For example, this is not a statistic, but the causal models describe the relationship between events. For example, the diet. Diet is a certain kind of event. So what kind of things I eat is an event. And LDA and HDA, the specific type of cholesterol, and how much cholesterol I have, and so on. And heart disease is whether I get a heart disease or not. This is another event, right? So this causal graph is describe the relationship between events. So this is quite, intuitive as well. Well, then, where have all the things gone? Wittgenstein famously said in his beginning of this Tractatus, the world is the totality of facts, not of things. So things are gone. Things are gone, completely gone. But actually, they are not gone. But they just stay implicit behind the scene. So Newtonian particles are objects, and they are represented by the phase space itself. And the statistical units are represented by the causal dog itself. The causal dog represent each individual human being like me. And so in this sense, the object defines the system of events and law. But without it may, objects themselves do not have formal representation. And that has some kind of problem when we have to deal with the interaction between distinct events and so on. But of course, there are quite important exceptions like the game theory, agent-based models, and so on. Well, they explicitly try to model agents or objects and so on. So I'm not saying that the objects are completely gone, but they are relatively kind of implicit behind the scene. Now, with that, now move on to machine learning. Deep learning, well, are very good at classifying things, like trees, cats, and cars, and so on. And in doing so, they build a representation, their representation in the inner latent layer. Machines build representations in the middle layer, and this representation is said to be key to understand their generalizability and interpretability. So what are these representations? Well, these are representations of things, right? Objects, cars, trees. So they seem to build their own ontology. They do seem to have their own ontology, and it's a same ontology. But the problem is that their ontology seems to be different from ours. So this is a famous problem called adversarial attacks. So on the left is a picture of panda, and the machine classifies it panda correctly. But you add a very kind of slight noise, and on the right you have well, seems like it's the same picture, right? But the machine says, well, it's definitely a given. So this is a kind of the very well-known problem in machine learning. But it suggests that deep learning model seems to be seeing different things than we do, because we see pandas here, but machine sees the panda here, but gibbons there. So this set the question. Okay.
What is the epsilon?
Epsilon is a very slight noise here. It's a white noise here. So you superimpose this noise.
What's the origin of the noise? How is the noise appearing in this whole process?
Oh, actually, so you kind of make this noise. You kind of trick the machines. This is not a random noise. Yeah, okay. You trick the machine. Yeah. So the machine can be tricked by making up this kind of noise. And making up this kind of noise is always possible, always possible. But to us, these two things look quite same, right? So that suggests that machines have a completely different ontology. Then this sets a kind of question, intriguing question. What is it like to be a machine? And this is kind of analogous to the famous question by philosopher Aristotle. He asked, what is like to be a bat? Bat has a very different sensory experience and so on. Can you imagine being a bat? It's very difficult, right? So, and this is a kind of very difficult question for us to imagine what it is like to be a machine. And this sets up this kind of the machine learning the research project. So the objects are encoded in the latent space, and that encodes objects and their properties. So then we can study the nature of this latent space. So first thing first. So this latent space encodes object and properties, and based on which machines make prediction and judgment. And so this is quite Aristotelian picture. And so we are interested in this latent space. And there are many studies in AI to try to understand this latent space. What does it look like? So what is its geometry? What is its curvature and so on, and manifold property and so on, and what is the symmetries governing this space and so on, which I do not go into. But my claim, or part of my research study, is that I think these studies give us some kind of hint to understand what are concepts. So we think we use concepts, but we don't know what they are actually. We don't have much mathematical modeling for that. So I think these studies on the latent space and the machine representation help us understand what concepts are. And there are various approaches in machine learning: the vector space, manifold, lattice, and symmetry, and so on. And interesting enough, these different studies have a kind of similarity to different philosophical traditions on the study of the concept. The vector space approach is quite Wittgensteinian way of looking at the concept. Manifold view is quite kind of reminiscent of Lotze and Hegel and so on. Lattice theory, obviously Aristotle, and symmetry view, interestingly Berkeley and Castiller and so on, but I do not go into these details. But anyway, I think that this kind of the representation study revived the kind of the object ontology and also the study of concepts. And also causal models, object-based causal. Well, I gotta skip because I don't think I have many time. But I think that in the causal model as well, I think we can have the object-based causal model as well. But I gotta skip this. So conclusions. So modern science has replaced the Aristotelian thing-based worldview with a Galilean event-based worldview. But maybe AI may be reviving the thing-based ontology. Well, here I'm not talking about physics, actually. This is a physics-inspired philosophy. So it's a paradigm in philosophy. I'm not saying that in physics, from Galileo and so on, the physicians stop thinking of an object. I'm not saying that. Rather, philosophers, inspired by development of physics, start thinking in terms of event from the modern period. And now the event-based ontology is a standard or paradigm in the current paradigm in philosophy. But maybe this might change in the next few decades. And mathematical studies on the representation and latent space may provide a formal framework for the thing-based ontology, thing-based worldview, and might prompt a reconsideration of some kind of Aristotelian object ontology. But this is a kind of rough speculation. And that's it. Thank you very much.
Thank you very much, Professor Otsuka. So the session is open for questions. Do you have any question?
Well, there are many questions. And the question will be, indeed, we have to discuss those things. There are many questions. From the very beginning, most of the things which I would want to discuss in connection with what you said is, again, related to the semantics, and the interpretation of the semantics. A statement like coming back to the concept is very spectacular, but we cannot run away from the concept anyhow. Everything you said is about concepts here. Now, to begin with a thing ontology and event ontology, my question would be, I would turn it around. There is one ontology. You said in the first slide that doesn't matter, but the point is we can stay with ontology, as you said, is about what it exists. Ontos, if we go back to the so whether you apply the art of understanding what the object of your observation is to a thing or to an event, it's one ontology in both cases, but in one case, the object is a thing, and in the second case, the object is an event. Now here, you go on and you say, well, so the thing, the object, is static.
Sorry?
Is static. The event is dynamic. We have heard this in those things. So in fact, you deal with ontology. The object of your study is in one case a static object, and in the second case is a dynamic object, right?
I do not want to imply that objects are static things. But Aristotle for sure took our object as a dynamic thing, because that object has its principle to become something. So the nature of seeds, of tree, acorn or something, has its kind of principle to become an oak tree. So it's not a static thing. Things has itself, it's a kind of the moment of principle, of the dynamic principle, the moment of change in itself. So I do not want to imply that object ontology is a static one.
Yes, but in examples you give, everything is alive, is something which has a dynamic element in it, right? If you take the ontology of Mount Fuji, that's Mount Fuji, right?
Yeah, but it's not a static thing. It's an active volcano. Wow.
Well, of course. But when you say that, you left the domain of ontology and you are in the domain of epistemology. Because when you give me this answer, I try to understand what you said. So what am I doing? I left ontology. The object of my question was related to ontology, but when I am trying to understand your answer, I'm in the domain of epistemology.
Yeah, I understand your concern, and that is well taken. But my claim, my fundamental, the belief is that there is no ontology without epistemology. So in this sense, well, you might call me Kantian, but the ontology, our ontology is deeply affected how we see the world, how we understand the world. And I think this is also inherent in Kuhn's idea. Kuhn, in using the word paradigm, what is important, what I take the most important component of paradigm is ontology. So the scientific field, each scientific paradigm defines what are the objects of this theory. For example, what is the Aristotelian paradigm? Well, it's a study of things nature. What are Newtonian mechanics? Well, it's a study of Newtonian particles, and so on and so forth. So I think that the scientific theory defines its ontology. And of course, scientific theories are very sophisticated theories, so it's quite epistemological. But I do not think that we, for example, in the folk physics and folk biology and so on, for example, when we think that, well, this is a kind of notebook and this is a PC and so on, I don't think this is theory-free at all. We always use a theory, and we always in an epistemological binded ontology, and that is what we have, and that is with this the theory-laden ontology we navigate through the world. So I think the epistemological question and ontological questions are deeply kind of intervened to each other, if that answers your question.
So it seemed to me that you said before that the ontology, the epistemology basically defines the ontology, or I'm confused by that.
It's interdependent. It's interdependent, yes.
But they are not two different domains.
Well, they are different. I think they are different, but they are not completely independent, I think. I think, yes, of course, there are quite epistemological interests, how we can understand object. This is quite an epistemological thing. And the ontological interest is what are there, independent of our interest or our perspective, our understanding and so on. I do recognize these are two kind of extremities of the spectrum, or maybe different perspective, but I don't think they are completely independent. Of course, I admit that there are. I'm not saying that I'm the only correct. This is the only correct view. I fully admit that this is quite opinionated view. Maybe you might call it Kantian or whatever. But yeah, that's my view.
But when I train a machine to do a machine to learn, right? And the machine learned what it learned, and I've seen a panda. And then you add the perturbation, this epsilon, and the machine sees now a chimpanzee or something else, a monkey.
Yeah.
So in the process of training, what are you doing? You are in the domain of epistemology because you are talking, you train an object to think. Isn't that epistemology?
Well,
That's certainly not ontology.
Well, so this is an epistemology, but I do contest that it is not an ontology. I think it is also an ontology.
How can it be?
Well, because it's not excluded.
Is ontos.
I think this is
It's not a process.
So if you separate these two things completely, only conclusion you can get is skepticism. Because if there's something that we cannot have any access, it's completely independent of epistemology, but they are out there.
But that is why this discussion is so essential. Of course, to a student in philosophy, if he would have asked you after the first geograph or the second, where you showed up there, Wittgenstein and whoever else, Aristotle or anybody, the student could have asked, what then? Should I concentrate on studying Wittgenstein, or should I go and follow Aristotle? The thing is that, the danger is skepticism. But the danger in this fuzzy understanding, fuzzy logic applied to epistemology against ontology is sophistry.
In what sense?
In the sense that anything, you don't know what is sophistry. Is something which is apparently a perfect truth, I will believe that, and it is not.
So you worry about relativism.
Pardon?
Relativism. Everything becomes relative to the perspective.
No. Sophistry doesn't. No. So sophistry is not a relativism. So sophistry. What did the sophists do? They convinced the Athenians of things which then came the Aristotle's type of philosopher and said, well, that's not true. That's a non-truth, what you convince the Athenians that is the truth. So it's not relativism, it's something which has all the appearances of being real, but it's not. So sophistry was so fascinating and so complicated that when it appeared in the Platon, Aristotle's times, roughly 400 or 500 years before the Christian era, in the 2nd century, you know that there were the new sophists which came up. So for 7 centuries, people thought about this problem. It was never solved. But here, indeed, there is, of course, today there are many types of theoretical approaches which bring together or cancel the difference between ontology and epistemology. Well, that's not an easy, in the context of artificial intelligence, this will be a real problem.
So, to clarify, I'm not canceling the difference between ontology and epistemology, as I stressed. And also the second thing, I see your concern, yes. There is a circular of absolute.
There is a what?
Secular and calibratus. So there are two extreme difficulties. One is the absolutist, which posits that there is a fundamental truth out there. There are this kind of the dualism between what exists and what we can know. So, and what exists should be completely independent from our perspective, our knowledge, and our interest, and so on. So this is the kind of absolutist view. And the other hand, other difficulty is a kind of relativism. So everything depends on us. So this kind of social constructivist view. Of course, there are two difficulties, and we want to avoid these two difficulties. So I think the truth is in the middle. So it's quite difficult to go through these two difficult monsters on your right and on your left. So you have to navigate through the middle in a very sweet spot. But I think this is what we should do in philosophy. So without going to the extreme view, we try to go in between. And I think we need some kind of the intervenence, how to say that, the mixture of ontology and epistemology. That is what I'm thinking, but maybe I have to stop here.
Yes, thank you very much, Professor Otsuka. So let's thank him again.
Thank you very much.